This is Unit 5.11, Ecological Footprints. So if everyone lived like Americans, how many people could the Earth support? And if you look at the world population, back in July of 2020, the world population was about 7.8 billion people. And it's grown a little bit since then in the last 2 years. So what you can do is write down how many people you think the Earth could support if they all lived like us, basically. So write something down, pause the video if you need to. Then when you're ready, restart the video. So the answer is really about 1.5 billion people. And how we measure this is called the ecological footprint. So sometimes you might talk about a carbon footprint, but this is more comprehensive, right? So it includes how much energy you use, how much space it takes to settle, how much timber and paper are used for different purposes, how much food and fiber we eat and we use for our clothes, how much seafood we use, and those are all our uses. So how quickly can nature generate new resources and absorb our waste? So how much carbon, how much land there is to build up, how much forest there is for that timber, how much cropland there is to grow the food, the fisheries for the seafood. So the ecological footprint in total is the amount of biologically productive land and water needed to support people with resources, as well as absorb or recycle the waste and pollution produced by the resource use. So really, we're measuring an area, and we often measure that in hectares. So a good idea is to see what is a hectare exactly. So a hectare is 10,000 square meters. If you looked at a picture of a soccer field, a hectare is a little bit bigger than a soccer field. It's like 1.5 soccer fields. If you looked at the grass area inside a 400-meter track, you would see that grass area is 1.12 hectares if you include the little semicircles on the end. But how much biological productive space is actually available on the Earth? So we have about 11.3 billion hectares. That includes all cropland, forests, and fisheries. And we're not including deserts or glaciers or open ocean because that's not productive space. And so per person, that's about 1.8 hectares available. And that's per person who's currently alive on the Earth. So if you increase population size, what does that do to the amount of space that's actually available per capita? If you said decrease, you are correct. So the biocapacity to replenish renewable resources is, if that's exceeded by a population's ecological footprint, then there's an ecological deficit, right? People are using more resources than the environment can provide. And so if you look at the Earth, you can see that different countries are exceeding their biological capacity. So the US, Mexico, North Africa, almost all of Europe, Middle East, India, China, right? They exceed the capacity of their ecology to support them. And then the ecological reserve, like how much is available, um, South America, parts of Africa, Australia, have greater capacity. So some different ways that this could go. If we continue on the path that we're on, you can see the red line going up, where right now, 1.5 Earths worth of stuff is being used. And if we continue on that trend, by the year 2050, we'll be using almost twice as much due to population growth and increase in lifestyle. But if we're able to conserve more, and it says rapid reduction, which is not something we're doing right now, certainly not since 2008 when this graph was made. We could get down to 1 Earth by 2050, but we are not doing that yet. Biocapacity by nation, you can see that Brazil has a fairly large biocapacity. That has to do with the Amazon rainforest, followed by China and the US, Russian Federation, and so on. But the footprint, of course, is different. China has a fairly large footprint, but the US footprint is second, and then India, and then Russia. So when you compare the footprint to the biocapacity, you can see how different countries are using their resources. The US by far has the largest footprint per person, 9.7 hectares per person. Remember, on the Earth, there was only 1.8 hectares for everybody on the entire Earth. So we're using, five times as much, five times as large footprint as is available to the average person on Earth. Ecological footprint per capita. So we saw that the US was pretty high, Canada is high, a lot of Europe, Western Europe is high, Australia is high. There are a lot of countries where the ecological footprint is lower, but a lot of those countries are also fairly impoverished. So the balance is, how do we find a way to make people's lives better, give them housing and food and education without destroying the environment in the process? If you look at ecological footprint by land type, so this is the type of land and how it's being used. So carbon is being used at a pretty high clip, right? Oil and gas, that kind of thing. Cropland is increasing. Fishing grounds increasing a little bit, but still not as large as the footprint due to carbon use. We also talked about how energy use is part of the ecological footprint. So you can see how energy use has really just exploded in the last 180 years. We measure energy in terms of joules. So an exajoule is a really large unit of energy. Back 180 years ago, we were using probably around 25 exajoules. Now we're using, almost 550 exajoules, so like 20 times as much. And yet the Earth's population has not grown 20 times in that size. So we're using a lot more energy relative to our population growth. The amount of coal and oil use has gone way up, as well as biomass and natural gas. Although in the last 10 years or so, like, coal use has gone down, at least in the US. Notice how the fossil fuels are the ones that are being used the most. So the issue, of course, is developing versus developed countries. And there's even in this analysis a thing called overdeveloped countries. So countries that are using way more than the average. So the US is one of those. You can see Saudi Arabia, even Norway's up there a little bit. And there are plenty of rich countries also, and they're still using too much footprint. This graph in particular is carbon dioxide emissions. So you can see how our lifestyle is putting out all kinds of carbon dioxide emissions. This correlation between average income and ecological footprint, right? As average income goes up, ecological footprint also goes up. So developing countries have smaller ecological footprints, although they are also developing countries. So we can see some of these issues here, what it means to be developed. Why do we have a larger footprint? Our food, we have a meat-rich diet versus a grain-rich diet. We have a larger energy use, especially our dependence on fossil fuels. And a lot of this energy goes into our diet as well, like intensive farming strategies, as well as automobiles and factories. So there's a greater need to fix carbon dioxide to keep it out of the atmosphere. And then finally, biomes. So the amount of carbon dioxide that you can fix depends on climate and vegetation type. So as we're destroying our forests, that's making our carbon dioxide fixation worse and increasing our footprint. You can see this graph of ecological footprint versus development, where you can see on the left, all those yellow dots are countries in Africa. And on the right are all these countries in Eastern Europe, or I should say Europe, European Union, which at the time of this graph included 28 countries. But some of the non-European Union countries in Europe are in the same area. North America has some countries. There's only 3 of us. but the US and Canada are definitely high up there. So you can find your ecological footprint at this website, sponsored by the Global Footprint Network, and we'll be doing an activity on that. All right, well, that is Unit 5.11, Ecological Footprint. Please let me know what questions you have.